Hello everyone. In this quick 5-minute video, I'm going to take you through a possible solution to the Step Up Dig Data challenge for CACI. Now, this is just using a Python approach. So I'm going to use a Python notebook. And I'm going to talk you through what my approach has been to tackle this problem. This isn't the only approach. There are multiple ways, but it's a good starting point if you've never done something like this before. So to start with, I've imported all the Python packages I'm going to be using in this notebook. So the main ones to really note here are pandas, which will basically be doing all my data manipulation, and sklearn, which is basically where my logistic regression model is going to be, which is going to be the core model I'm going to use. And then here I've got XGBoost, which is just some funky tree-based method, which I'm also going to use just for comparison purposes. Right. So the first thing I'm going to do is I'm going to import my data. So I'm going to use pd.readcsv, so the pandas read CSV functionality to do that. Okay, and I've got my CACI dataset 1, so that's what I've imported first. Okay, so as we can see here, this is what it's looking like. Okay, it's got 10,000 rows and 52 columns, which is what we were kind of expecting. Yeah, so then I'm going to check and be like, okay, they're all numerical, they're between 1 and 100, and I've got gender and I've got age, okay, which is categoric. Okay, so that's what I was expecting. And what am I trying to model again? Ah, yes, interest and sustainable range. Okay, this is the flag I'm trying to model. Okay, so the first thing I'm going to do is I'm going to convert all of these numbers to between 0 and 1 instead of 1 and 100, because it's just better for modeling purposes. Some models prefer it when they're between 0 and 1, but you know, it's nothing major. Okay, so that's what this code here does. Okay, just extraction of numerical columns, and then basically, you know, it divides them all by 100, all of these numerical columns. Okay, so the next thing which I'm going to do, which is quite important, so I can use those gender and age columns as I'm going to convert them into numerical values. So I'm going to do that using one-hot encoding. So I've built a little function which I've used previously, which I use quite a lot in my line of work, and basically all I'm going to do is just use sklearn's one-hot encoder inside that. So you don't really know what's going on, but what you need to understand from this or appreciate is the fact that I'm converting all of those categorical columns into like dummy variable columns. Okay, so now they're numerical, so now I can use them in a model. So here we can see we've got my gender F and gender M, gender O columns, which I've created using this one-hot encoding. Okay, so here we could say, for example, if we're looking at this customer, you can see that they're female because there's 1 here, not male, not 0, but I can also see that they're between the age of 55 and 64. Okay, so when I feed this into a model now, because it's purely numerical, we'll understand what's going on. Okay, so I'm just extracting my X and my Y values, so just to make really clear what I'm modeling. And yeah, now the important part, I need to just, well, good practice is splitting it into training and test sets. So reserving some data which the model will never see until you want to measure how well it's performing. Okay, so I'm reserving 20% of the data, which is what this test size here is, so 0.2, so that's 20%. So yeah, that's what this is split, and it's split nice and randomly, and it's, yeah, so it should be good to go. All right, so now I'm going to fit a basic sklearn logistic regression model. Okay, I'm just going to use the age and gender just to get an idea of what my baseline should be. And here I've omitted basically one of the genders and one of the ages, just so that when it comes to fitting the model, there's no collinearity. Okay, so it's just a very basic model. And yeah, as we can see here, I'm just stating the logistic regression sklearn class. So just stating it. So I've got, like, I'm stating what that model is, and then I'm fitting it. Okay, so I'm fitting it to just this age and gender, and basically, you know, is it going to see it? I'm fitting it towards the Y train. Okay, right. Okay, and then I'm just creating a function here for accuracy, so I can report on that. So as I can see, when I'm using this model on the training set, which I've got here, I'm getting 61% accuracy, which is not great, but it's an all right baseline. Okay, and then I can see this basically metrics.classification report is just so you can go into more granularity and see where it's performing. So here you can see it's better performing like predicting zeros than ones. Okay, right. So this is just, it's actually on the test set and it's doing similarly well, which is good. So that means that it's not overfitting. Okay, and this is a rock graph, which is basically something which I'm not going to go into too much detail, but basically it should be pointing towards the upper left corner. So right now, this is basically a completely random model, which is rubbish. This is our baseline model, right? And as we can see, as we go through the models, we can see how that improves. Okay, right. So now what I'm actually going to do is I'm going to look into the data to see what's correlated to what, so that I can choose some variables which are going to be, strong and therefore will make a good model. So this is me choosing variables to make a good model, okay? And basically, when I look at these, I'm looking at this column here, interest and sustainable range of the heat map, okay? So the more red or the more blue the color, the better it will be. So for example, if I'm looking at this one, this column, this row here, I can see that if there tends to use a refillable water bottle, it's going to be quite highly correlated to being interested in the sustainable range. So that's a variable I'm going to use. So yeah, and then this basically just selects the 10 biggest correlated and the 5 least correlated variables, and basically makes a list of them, which I'm going to use to drive my next model. Okay, so that's what I've done here. I've basically just extracted the variables which I think are going to be good for modeling. Okay. Yeah, and again, I've made a logistic regression. I've now fitted it on those X values, those X variable columns I've chosen, and the Y, okay? And then you can see here, we're getting a better accuracy, getting 70%, which is good. This is reassuring, and it's more balanced now as well, which is good. And then it's getting similar results on the test set. It's actually doing better. So this model is performing quite well. Okay. So yeah, and here we can look at our coefficients, just as a little sense check, and we can see, if they're 75, it's negative. Okay, that's good. And yeah, just good. Okay, it tends to use a refillable water bottle most days. Okay, that's positive. Therefore, if they use a refillable water bottle, they're more likely to be interested in our product or sustainable range, which does make sense, really, doesn't it? Okay, and now we're looking at the ROC graph, and as I can see, this orange line is tending to more towards the top left corner. I'm getting similar results on the test set here as well. So that means that the model is just performing better than that baseline model I had initially. All right, now I'm going to just quickly show you a tree-based method. And here you can see on this, so again, it's getting 100% accuracy. So I'm a bit suspicious. If you ever get 100% accuracy, be a little bit suspicious, okay? Right. So as you can see here, this is too good to be true is what I'm feeling. So I think it's overfitting, okay? And here on the test set, we can see its performance has decreased. Therefore, what I would assume here is that the model is picking up trends which it shouldn't necessarily be seeing. Okay, although it's getting really good accuracy. And then when we're looking at its feature importance, so that's another point with tree-based models basically is they're very good at picking up things we don't really know, but they're a bit more hard to interpret. So here we've got feature importance, but I don't know what effect these variables are having on the model. I just know that they're important essentially. So as you see, unemployed, that's driving the model. So a lot of this is quite inexplainable. So it's not something I would want to use in a business case necessarily. Now, so after seeing all of those models, I think the chosen logistic regression model is best. Okay, so then what I've done here, I've imported the data set 2. So now I'm going to use my chosen logistic regression model on this data set to see who I think is most likely to turn up to the launch. Okay, so then when I've fitted that, I've just imported the data, getting out the columns I want, and then also I've just seen how all the other models are going to do on it anyway. But the column I care about really is this chosen logistic model probability here. And basically I've ordered them from 100 to 0, and I'm going to see who's the best. So initially I did it on mean, but after assessing the other models, I think that this is by far the best model. Okay,